Hello and good day. It's great to be back teaching math, even if it is in front of an empty classroom. It's probably better you can't see my face anyway because I've got a wicked beard going on right now. But today we're going to be talking about solving equations with variables on both sides. This is the culmination of the equation solving unit in the sense that after today, basically any equation that you come across, you will have the tools to solve. Because we've talked about things like combining like terms, we've talked about things like the distributive property, we've talked about the importance and the comfort of writing an equation as a two-step equation. And kind of like if I were to use Mario terms, the Bowser of equations would be variables on both sides, and that's what we're doing today. So the goal is essentially to move all variables to one side of the equation, because what that's going to do for us by moving all variables to one side is it's going to create that comforting two-step equation for us to solve. Okay? So the goal here is to move all the variables to one side so we have a two-step equation to solve. So for example here, let's look at the first one. It says 18x equals 14x plus 20, right? Essentially what this is saying is that, here's our equal sign here, right? So on the left side, we have 18x's. On the right side, we have 14x's with a constant of 20, okay? And so by using opposite operations, by subtracting 14x's from both sides, that gives us 18x minus 14x is 4x on the left. All of our x's from the right have been canceled out because we moved them. We had positive 14. The opposite of that is subtracting 14. So we move them over to the left, and we're left with our constant of 20. Okay? So things you've done before, right? You've moved things from one side of an equation to the other. Normally, when we deal with variable terms, we're dividing, right? If we had 14x in an equation we've seen before, we would divide by 14 to get x by itself. But the reason why we're subtracting here is because we're not getting x by itself. We're not trying to separate the 14 from the x. We're moving those 14x's from one side of the equation to the other. So we're going to subtract them. And now we're actually left with a one-step equation, even better. Now that we want to get x by itself, we want to separate it from the 4. Here's where we'll be dividing by 4. And 20 divided by 4 equals 5. Okay? And then, of course, plugging that back in to check, 18 times 5, that would give us 90 on the left side here. And then 14 times 5 is 70, and 70 plus 20 equals 90. Right? So the whole goal, the whole concept of a two-step equation is to, using opposite operations, adding or subtracting to move all the x's to one side. Okay? Now I'm going to erase this here so I can show you kind of a common mistake that folks make in the hopes that you avoid this. So don't write this down, but just maybe kind of recognize the difference here. The most common mistake that I get with variables on both sides is people mistake it for combining like terms, right? They will see an 18x and they'll see a positive 14x, and they'll take 18 plus 14 to get 32x. The problem with that is that our two x terms are on opposite sides of the equal sign. Okay? And since they're on opposite sides, to combine them, to move them, we need to use opposite operations. Thus, we're not going to be adding 14x to 18x. We'll be subtracting 14x from both sides to move these x's from the right over to the left. So it's not the same thing as combining like terms we talked about in PO21, right? In that case, we would see, our 18x and our 14x on the same side of the equal sign, right? That's what we saw in PO21, the same side. And so here we would add 18x and 14x to get 32x because they're on the same side and we're combining them, right? But variables on opposite sides of the equal sign, variables on both sides, because you're moving it, you'll be using opposite operations there. So don't fall in to that trap. Many before you have, but you will not, right? This little nifty tidbit here, I haven't talked about yet, but this kind of comes after you see the mathematics behind it, you know, the opposite operations to move from one side of the equation to the other. But if those of you that play basketball in particular, like scores get very, very high. And so if you're ahead 17-10, that's really just the same as being ahead 7-0, right? If your coach were to call timeout, rather than saying, all right, the score is 17-10, probably gonna say something more like, all right, we're up by 7, right? Because it doesn't really matter what the numbers are. A difference of 7 points is just a difference of 7 points, okay? So if you look at the equation 17x plus 1 equals 10x minus 6, I've bolded the 17x and the 10x there to show you that having 17x's on one side and 10 on the other is kind of the same thing as having 7 x's on the left and then none on the right, right? Because whether it's 17-10 or 7-0, but in both those situations, you've got 7 more on the left side. If we apply that logic to the one that we just did together, if you look at 18x equals 14x plus 20, you know, how many more x's are on the left side? 18 compared to 14. 18 is 4 more than 14. So you can think about it as, okay, 18 is 4 more than 14. That's the same as having 4 on the left and none on the right, which if you notice is the same equation that we got using opposite operations. Okay. Let's look at the second one here. Negative, and I'm going to scroll down a little bit. See if I remember how to do this. I got to clear the ink, then put my pen down, then scroll down. Oh, see how to practice. Okay. So we got negative 10n plus 18 equals 8n. Negative 10n plus 18 equals 8n. I see here's my equal sign, and my n terms are on opposite sides. Okay, so I need to use opposite operations here to get them all on the same side. And it makes more sense in this case to move my negative 10n over to the right, right? Because if my goal is eventually to get n by itself, I don't want to move my 8n's over to the left side where I already have that constant sitting there, right? Then I'm just going to move them back over again. So with a little bit of logic and understanding what we're doing here, we see it's going to be more beneficial to us to move our n's over to the right side away from the constant. So that's going to help me get n by itself faster. So what's the opposite of a negative 10n? Opposite operations to move that over. The opposite of a negative 10n is a positive 10n, which I'm going to need to add to both sides here. On the left side, negative 10n plus 10n is 0n, cancel out. I'm left with just my constant of 18. And on the right side, 8n's plus the 10 I'm adding to them is a total of 18n. Okay? So 18 equals 18n. Now I want to break the 18 and the n apart to get n by itself. So the opposite of multiplying by 18 is dividing by 18. On the left side, 18 divided by 18 is 1, and 18n divided by 18 is n. 1 equals n equals 1. Same thing, doesn't matter which way you write it. Those mean the exact same thing. So the value of our variable is 1. Right? If we had used the basketball score analogy, I like it so much. Up at the top here, take a look at our n terms. We've got negative 10n here and 8n here. Which side has more n's? Which side has more n's? Which value is larger, negative 10 or positive 8? Positive 8, right? So this side, the right side, we've identified as having more n's. The next question is, how many more? How much greater is positive 8 than negative 10? And maybe for this analogy, golf would be a little bit better here. You golfers there, if you're 10 below par, minus 10, playing against someone who's 8 above par, positive 8, you know, what's that difference there? How many strokes are you ahead? So the right side has more, and there's a difference of 18. Positive 8 is 18 more than negative 10, which is exactly what this statement here says, right? Having negative 10 n's on the left and 8 on the right is the same thing as having none on the left and 18 on the right side. If you can't see that yet, that's okay. That's why we have the mathematical step behind it, right? That opposite operations there. But if you can, if this works for you, then that's good news. All right, sorry about that interruption. Not that you lost any time there, but I'm back. So let's look at the next one. 9y minus 8 equals 4y plus 42. Look where the equal sign is. Look at how many y's are on the left, how many y's are on the right. In this case, it really doesn't matter which side we move the y's to, since we have constants on both sides anyway. Whether we move our 9y's to join the 4y's on the right, that's an option. If we move our 4y's to join our 9y's on the left, that's an option. It's not really going to save us any time doing it one way versus the other because we have those constants on both sides anyway. But because we are positive people, typically we're going to want a positive coefficient to y, meaning that moving our 4y's over to the left, I'm going to be subtracting 4y from both sides here. Opposite operations, the opposite of a positive 4y is a negative 4y, right? So subtracting 4y from both sides. On the right, it cancels out. On the left, 9y's minus 4, I've got 5 of them. And 5y minus 8 equals the constant that I've got left, positive 42. Okay? And here we have a two-step equation to solve. Start with your constant, move it to the other side. Second step, multiply or divide, right? So the opposite of subtracting 8 is adding 8. Okay, cancel out. 5y equals 42 plus 8, which is 50. Divide both sides by 5 to get y by itself. And y is going to equal 10, right? We didn't check the last one specifically, so we'll do it here. If y is 10, then 9 times 10 gives us 90 minus 8. And that's supposed to equal 4 times 10, which is 40, plus 42. Well, 90 minus 8 is 82. 40 plus 42 is 82. Ding, 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 ding. We got it. 82 equals 82. So it works out. Okay? The equation is balanced. If we go back to basketball, look at this. 9y's on the left, 4y's on the right. Which side has more y's? Which side has more? What's greater? Positive 9, positive 4. Well, positive 9 is, right? And a score of 9 to 4 is really the same as just 5 to 0, right? 9 is 5 greater than 4. So having 5 y's on the left and none on, that's supposed to go through the center, and none on the right, it's really just the same thing, okay? So we have the mathematical step of opposite operations, physically subtracting 4y from both sides to get 5y minus 8 equals 42, or thinking about it, which side has more, how many more? 9 is 5 greater than a 4, so we got 5 and 0, okay? Next one. Last one we will do together, and then you'll have your Google Classroom quiz, which you will be required to get 100% on. So But we'll talk more about that when I'm done doing this one. Negative 4n minus 3 equals 8n plus 21. I've got constants on both sides again, so it's not really going to save me any time to move my variables to the left or to the right. However, if I want to keep my coefficient to n positive, there goes my marker again, I'm going to add 4n to both sides. Because negative 4n plus 4n cancels them out on the left. Make sure you bring that negative sign down with that 3. And then 8n plus 4n is positive 12n, and then plus 21. Okay. I've got a two-step equation. Negative 3 equals 12n plus 21. Start with my constant. Move it to the other side. Using opposite operations here. So negative 3 minus 21 is a negative 24. That equals 12n. Those have canceled out. Divide both sides by 12 to get n by itself. And we get negative 2 as a value for n. Let's check this again, just because it's fun. If n is negative 2, then a negative 4 times negative 2 is a positive 8 minus 3. And that's supposed to equal 8 times negative 2, which is negative 16, plus 21. Well, 8 minus 3 is 5. Negative 16 plus 21 is positive 5. And zippity-doo-dah-day, we have it correct. 5 does indeed equal 5. One more time, the basketball analogy, right? Or in this case, golf, because we got a negative coefficient there. Which side has more n's to start with? What is greater, negative 4 or positive 8? Positive 8. How much greater is positive 8 than negative 4? What's that difference between positive 8 and negative 4? That's a difference of 12, right? Think of where negative 4 is and positive 8 is on the number line. Okay, 8 is 12 greater than 4, which is why we have 12 greater than negative 4, which is why we have 12 n's on the right and none on the left. So if that works for you, use it. If not, don't. You have opposite operations to help you as well. Okay, your questions on your quiz are just going to be I think we have 4 left here on this first page. These 4 questions are going to be on your Google quiz. So do the work on the page here, and then just go to the quiz and select your answer. You must get 100% on the quiz. So after you submit it, check your score. If it's not 100%, go back and it'll show you which questions that you missed. Go back and give it another try. And yeah, we're just going to stick with those 4 today. Yes. Sorry, dead air is not very good on a video, but I'm just trying to think. Yeah, those 4 today, and then we will jump into more practice tomorrow. We kind of get a little more involved here. We combine things like combining like terms. In the distributive property, we'll talk about what happens when you have the same number of variables on both sides. That's always fun. And then we will close PO22 with kind of a general review of all the equations that we've talked about thus far. Because like I said, now that you know how to handle variables on both sides, okay, you can solve any equation that comes your way. So work on this page for these 4 below the 4 that we did together. Then hop over to Google Quiz, input your answers there, retake the quiz if you need to in order to get 100%. Khan Academy is due on Thursday. You're watching this on Wednesday, so it's due tomorrow. Yikes! So if you haven't done that and you've got time at the end of class, you can work on that. Otherwise, I hope to see you again soon. I'll be looking forward to watching scores coming in on the quiz. That, folks, is How You Math. Do not forget to like and subscribe.